ChargerLAB recently conducted a series of tests on the Huawei MateBook X Pro. This laptop is equipped with a 140 watts charger, which is currently the Huawei charger with the highest charging power. Today we will conduct charging tests on the original 140 watts charger to see how it performs. It can support a charging power of 20 volts 7 amp. However, it requires a 7 amp cable to reach 140 watts. It comes in pure white. The case is made of PC fire retardant material with a smooth surface. It is designed with a fixed 2-pin. It only has one orange USB-C port. The words Huawei Supercharge and 140 watts are printed below the port. The specs info are printed below the prong. Model is HW-200700CP0. It can support input of 100 to 240 volts 50 or 60 Hz 2.5 amp. It can support output of 5 volts 2 amp 9 volts 3 amp 15 volts 3 amp and 20 volts 7 amp. The connectors of the dual USB-C cable are made of PC material and are engraved with 7 amp. The plastic sheets of connectors are orange. The length of the cable is about 1.8 meters. ChargerLAB Power's EKM003C shows that it can support 20 volts 5 amp 100 watts PD and USB 2.0. The size of the charger is about 60 by 60 by 31 millimeters. And the weight is about 188 grams. So the power density is about 1.27 watts per cubic centimeter. ChargerLAB Power's EKM003C shows it can support UFCS SCP SCP QC 2.0 QC 5 DCP PD 3.0 and PPS charging protocols. And it has 5 fixed PDOs of 5 volts 9 volts 12 volts 15 volts 3 amp 20 volts 4.5 amp and a set of PPS. It can support 4 sets of UFCS, 5.5 to 7 volts 4 amp, 7 to 10 volts 6.6 amp, 20 volts 7 amp and 21 volts 6 amp. We use it to charge phones, tablets, game consoles and laptops during the compatibility test. The test results are as follows. Google Pixel 8 Pro and 7 Pro cannot be charged with it. The highest charging power is 78.41 watts for the Huawei Mate 60 Pro. Phones compatible with the PPS fast charging protocols such as Nubia Z30 Pro can reach a power of above 70 watts. The Lenovo Legion Go has the highest charging power of 85.8 watts. The charging power of the Nintendo Switch is about 15 watts while the charging power of the Steam Deck is about 29 watts. The Samsung Tab S8 has the highest charging power of 33.6 watts. The other tablets can also reach their maximum charging power. The Huawei MateBook X Pro has the highest charging power of nearly 140 watts. The highest charging power of the rest of the laptops is 89.63 watts. Next, we'll use it to fully charge the Huawei MateBook X Pro. The charger and the laptop will be put into a 25 degrees Celsius thermotank throughout the test. Here is the charging curve made by the PC software of KM003C. The voltage is always about 20 volts. The charging curve can be divided into 8 parts. In the first part, the power was about 80 watts for the first 3 minutes. Then the power increased to 136 watts and continued until 13 minutes. The power then dropped to 58 to 78 watts and lasted until 22 minutes. Then the power increased to 136 watts and continued until 25 minutes. The power then dropped to 90 watts and lasted until 31 minutes. Then the power increased to 136 watts and continued until 32 minutes. Then the power gradually drops to 120 watts and 100 watts in turn. The final part begins at 38 minutes and the power slowly drops to almost zero. It takes 1 hour and 35 minutes to be fully charged. It can charge the Huawei MateBook X Pro to 50% in 27 minutes and 80% in 44 minutes, and it reaches 100% in 1 hour and 35 minutes. Next, we'll use it to fully charge the Huawei Pura 70 Pro Plus. The voltage is always around 18 volts. The charging curve can be divided into 4 parts. In the first part, the peak power stayed at 92 watts for the first 1 minute. Then the power gradually drops to 68 watts and 42 watts in turn. The final part begins at 42 minutes and the power slowly drops to almost zero. It takes 38 minutes to fully charge the Huawei P70 Pro Plus. Next we will test its standby power consumption. The power consumption at 220 volts 50 Hz is 0.12 watts and 0.006 watts at 110 volts 60 Hz, which is about 1.05 and 0.053 kilowatt hour and 1 year respectively. So you do not need to worry about the waste of the electricity. Then we are going to the conversion efficiency test. We tested the conversion efficiency at two inputs, 220 volts 50 Hz and 110 volts 60 Hz. Below are the test results. The conversion efficiency varies from 85.52% to 92.91% at 220 volts 50 Hz, and the conversion efficiency varies from 84.84% to 91.86% at 110 volts 60 Hz. The charger achieves a conversion efficiency of up to 92.91% under the two voltages, which is at the mainstream level for similar devices. Now let's do the ripple test. The lower ripple means better quality. Firstly, let's check out its ripple without load. When the output is 5 volts 0 amp, the lowest ripple is around 62 mV peak to peak. When the output is 20 volts 0 amp, the highest ripples are around 72 mV peak to peak. Then move to the ripple test when loaded. When the output is 12 volts 5 amp, the highest ripple is 76 mV peak to peak. When the output is 9 volts 3 amp, the lowest ripple is 26 mV peak to peak. Overall, the performance is acceptable. Then we are going to the maximum temperature test. We put the charger into a 25 degrees Celsius thermotank throughout the test, and recorded the highest temperature on the front and back after charging at 20 volts 4.5 amp for an hour. First, let's take a look at the temperature under 220 volts 50 Hz after an hour. After 1 hour of charging, the maximum temperature on the front is 64.8 degrees Celsius, and the maximum temperature on the back is 61.7 degrees Celsius. Next, let's take a look at the temperature under 110 volts 60 Hz. After 1 hour of charging, the maximum temperature on the front is 66.1 degrees Celsius, and the maximum temperature on the back is 71 degrees Celsius. Creating a bar chart to represent the data, it is evident that this charger reaches a maximum temperature of 71 degrees Celsius when operating under 110 volts 60 Hz. The maximum temperature is very close to the upper limit of 77 degrees Celsius, but it still complies with the IEC 62368 standard. Well, that would be all the tests for this charger. The charger is compatible with most charging protocols. Since it supports UFCS 140 watts protocol and proprietary protocol, it can provide higher charging power for Huawei products. Both standby power consumption and conversion efficiency are at mainstream levels. The results of the ripple test are also acceptable. The temperature after charging for an hour is above 70 degrees Celsius, but as a high-power desktop charger you won't be moving it around often, so temperature isn't a big issue. In addition, this is the only charger that supports the 140 watts UFCS protocol, and it is also the highest power UFCS fast charger. However, except for the Huawei MateBook X Pro, no other device can support the 140 watts UFCS protocol. Okay, that's all for today's video. Please drop a like, leave your comments, and subscribe to us. See you next time. Bye.